Hi guys, welcome back to my channel. In this video, we are going to look at Python's dictionary operations. Please note that none of the examples in this video is intended as an advertisement for any product or service. Okay, let's get started with dictionary, which is a mapping type because a dictionary maps keys to values like, okay, to save time, I have typed some of the videos here and just copy here. So here you can see a dictionary, just a series of key value pairs. There are multiple ways to create a dictionary, like you may use the dict constructor function with variable assignments here, or you may use the dict constructor function with a list of tuples. If you are not familiar with list or tuples, you may wish to check out my last two videos. And a third method to create a dictionary can be using just another dictionary. Okay, let's see what stuff, stocks, and commodity now becomes. Okay, so they are all just, you see, initialized and created. And one more is to use the zip method to zip up, to match up two lists into a list of tuples. And then this list of tuples, is fed to the dict constructor function to create the dictionary. And one last way of creating dictionary is to create a dictionary literal like this. Okay, this one is a bit long. So now programming book becomes like this. So since we created a dictionary, how can we just use it? What can we do with it? First, you can test whether dictionaries are equal by using the double equals operator. Double equals. Let's suppose A start start 0 and 5, and B is initialized to the same dictionary, and they will just you see equal each other. That's true. Now suppose we have a C which is also equal initialized to the same dictionary, and can we do this? Yes, we can. Okay. So we can compare dictionaries just, you see, with the double equals sign, and we can just compare multiple dictionaries by using the double equals sign multiple times. This can be done to strings or numbers as well. Then let's create a new dictionary out of a list like this, integers. A very simple one. Zip integers. Suppose we have such a kind of a dictionary. Squares now becomes this. So here, this formula is an example of list comprehension, which I touched upon in my video on Python lists. It calculates the values in the list out of the values in another list, like integers. The squares dictionary now has integers from 1 to 4 as its keys, and the squares of these numbers as their corresponding values. With the newly created dictionary at hand, we can do this. For example, for squares, we can retrieve the elements for key 2, that is, you guessed, 4. And we can add an element to a dictionary simply by putting a key in a subscript. The key does not exist in the existing list of key value pairs. And we just assign it a value. Now squares has one more key value pair that's newly added. And we can change the value of an existing element by, let's just change the value for key 4 to 16.0. You can see this is a floating point and the original value is an integer, but that's okay. It's still just added here, okay, updated. We can get the length of a dictionary using the good old len function. Got five elements now. And you can check if a key is in a dictionary by using the in operator. 3 in squares, it returns true. And we can also just check whether 4 not in squares. It should be false because 4 is a key here. So here, not and in are just both keywords in Python. In is used for membership check, and not is a Boolean operator in Python, which inverts the truth value of a Boolean expression, like in squares. Also note that you cannot check if a value is in the dictionary. Let's try 25. 25. So that's the value here, right? In squares, it should return false. And we can delete an element using the del keyword. It's for delete for short. Let's just delete the value and key for key 4. Now squares becomes this. And the key and value pair 4 is gone. We can compare these two dictionaries. How can we obtain the key? You may have noticed that I typed D twice here. Okay, it's not a typo. I just did it on purpose. Okay, we'll know very soon. Now, D is like this. So here, the range function gives you the integers from 1 to 8, and 9 is not included. To get all the keys, we do, and you get a list of strings wrapped up in an object of the dict keys class. And to get all the values, you do this. Similarly, you get a list of integers wrapped up in an object in the dict values class. And to get all the keys and values at the same time, we do this. And you get a list of tuples like this wrapped up in the dict items class. So here you do not directly get these lists. Instead, you get instances of these classes. But these classes are iterable. That means you can get these elements in the loop. So you may have noticed that in the string A, B, C, D, D, E, F, G, the letter D is repeated once. However, the above D keys, D items operations showed only one D, right? Only one D as the key, and the D values didn't show the integer 4 as a value, okay? So can you explain what happened? If you need an explanation from me, please let me know in your comment. So as of Python 3.8, you can reverse the order of the elements in a dictionary. We do reversed dict. As of Python 3.8, you can even reverse the order of the elements in a dictionary like this. Reversed dict, dict. Now reversed dict like this. So you can compare the order of the elements here with the original dict. It's just in the reverse order. You may use, okay, let's just create another dictionary. You may use pop item to pop the last elements from a dictionary, which is E5 here, and it returns a tuple like this. Now T becomes this. You can also pop an item with the specified key, like so you just popped off the key 3, the key C, and the value 3. Now T becomes, so C3 is gone. If you try to pop an item whose key is not found in the dictionary, you will get a key error like this. So you can see key error. But if you do this, you will not get the key error. You just get the default value. We provide 7 as the default value here. But if you do, you get a 4. Why? Because although you provided 7 as the default value, the value for D can be found in the original dictionary. So that corresponding value will be popped. And now T becomes even thinner like this. You can update a dictionary by using the update method. And we need to use a dictionary to update a key value pair. Now T becomes this because we just update the dictionary with a new key value pair. And we also update an existing element using this, and we give B a new value. Now T becomes this. And you also just do this. A2. And you get a new value for A now. Of course, you can always use the subscripting methods like T. Now we just get D back in. Now T just gets D5 inserted. You can retrieve the value of a key in a dictionary with the subscripting methods like T, B. You get 4. That's for sure. But you'll get a key error message if you're retrieving a value whose key is not found in a dictionary, like T, G. You get a key error. You can avoid this by using the get method. So for C, you get 3. And for G, no error will show. Of course, no error messages popping up means greater difficulties in debugging. One thing to do to get around that is provide a default value to get. So you get a 0. So in a particular program, if 0 shows up, you know something is wrong. By the way, let's see what type of value get returns when no default value is provided. Let's just use the good old type method. If we get a key that is not there, you get the class none type. So here the none type is the type of a value called none. So none is a keyword in Python, which means no value, no information. We'll come to none in greater detail in the upcoming video. A method similar to get is the setDefault method. Suppose we have an empty dictionary like this. If we do setDefault A, oh, I must have typed something wrong. A. A method similar to get is the setDefault method. Suppose we have an empty dictionary. P setDefault. So you can see here, if we call a setDefault with a key and a default value A, since A, a small a, is not found here, so the default value A is returned. And now P becomes, you see this key value pair were added in the dictionary. Since the key A is not found in the empty dictionary, so the set default method pairs up the key A with the default value A and put them in a dictionary, okay, here. And you can see that the difference between set default and get, right? Can you tell the difference? Python 3.9 introduced a union operator for dict objects. For example, here we've got a dictionary called AB with the key A for apple and key B for boy. And another dictionary called BD, B for baby, while D for dog. Now let's do a union between these two dictionaries. A, B, we just use this pipe sign to do union. Now you can see this union operation produces a new dictionary like this. So here, as dictionary AB and BD, both have the key, B key. When going through the union operation, the B key and its corresponding value in dictionary BD, which is baby, overrode the B key and its corresponding value in dictionary AB, which is boy. So what if I do BD union AB? So will the result be the same? You may try that out yourself. Here, I just commented out. Okay. So you can also assign the results of a union operation back to one of the dictionaries, like AB union equals BD. Now you got AB, just as the new dictionary. So we do this to concatenate dictionaries and eliminate unwanted keys and values in the process. Another way to do union on dictionaries is to use the so-called dictionary unpacking. So operations like produces this. This just equals this one. Now let's look at an example program which simulates a simplistic video recommendation process. This program uses a dictionary as the data structure to store these attributes of videos, including title, views, years, likes, click-through rates, duration, average view duration. It takes a search term from the user, searches the video data for videos to recommend based on the search term, as well as a couple other recommendation criteria, and lastly, prints out the search results it found. The program starts by declaring a dictionary with keys and values as these here. You may have obtained the data from a query to a local or external database. I'll talk about that in the upcoming video. Then these recommendation criteria are set up here. These parameters can be conveniently changed later as situation demands. Well, I should say such criteria are pretty high for the data here, but in real life, there are billions of videos out there for selection. Of course, video hosting platforms like YouTube will have very sophisticated algorithms for selecting recommends. Now, let's look at the behavior of the program. Here, it uses a while loop with a conditional expression, like this one, to compare user input with the string Q. User input is obtained through Python's built-in input function with its prompt string. This is optional. And inside the while loop, an empty list is declared to hold search results as the videos to be recommended to the user. The next section of the while loop contains a nested for loop. The outer for loop iterates through the video data lists, and the inner for loop iterates through each dictionary in the list. I explained how a dictionary is iterated through in an example program in my last video on list operations. Here you just get the items and use a temporarily created tuple to get the keys and values out of the items. Inside the inner for loop, the key title and its corresponding value, v, to the lowercase, are used to decide if the video's title contains a search term. So the search term is also put to the lowercase. And I explained the use of the find function in my video on Python strings. If the v does contain the search term, it then calculates the average view duration to the video duration ratio and rounds it up to 2 places after the decimal point using Python's built-in round function. Here, the views per year is calculated by integer divides the views by the years of the video. You can see that the get function, the get method, is used as an alternative to the subscripting mechanism here. So these two can be both used to retrieve the value of a key. When everything is ready, the if statement just compares the stats of the video with their corresponding preset criteria here. So these comparison expressions are joined with the AND keyword. If any of these comparison expressions evaluates to false, the whole conditional expression will evaluate to false. If it does evaluate to true, the recommends lists will collect up eligible videos. After the video data list is exhausted at the outer loop, the recommends list is checked to see if it is empty or not. If it is not empty, another for loop iterates through the lists and prints out the titles of the videos in it. Or else, a message is printed to the console telling the user, videos meeting recommendation criteria not found. Okay, guys, let's just test the program. Let's do tutorial first. So you can see we are lucky. We have these two. And let's do machine learning. We cannot have one because although we have a machine learning video here, but it does not live up to the criteria here. Okay. How about NumPy? Yes, NumPy survived. the search. Okay, that's good. And how about beginner? Not found. Okay. Okay, guys, that's all for this video. Thanks for watching. If you like this video, please hit that like button. And welcome to subscribe my channel for more interesting stuff about Python. See you next time.